Let's take a look at the graph of f of x is equal to 1 over x. If I wanted to find the domain, of this function, I would have to take the function f of x is 1 over x, set the denominator equal to 0. So denominator equals 0, and then that would give me bad x. Now to get the domain, what you want to do, the domain is a set of good x's. So you take really the number line from negative infinity to infinity, but you need to remove 0 from there, which is bad x. So you do a little surgery at 0. So really what you have is this. Okay, the number line looking like that, and that's 0 that you just excluded. And the domain will be all the real numbers except 0. So when you write that in interval notation for the domain, it would be from negative infinity to 0, union 0 to infinity. So that's the domain. Notice that bad x was 0. Now, if you want to find the vertical asymptote of this function f of x, what you do, you first make sure that the numerator and denominator do not have any common factors, and then you take the denominator and you set it equal to 0 and you solve for x. In this case, you don't have much solving to do. X equal to 0, yes, it was bad x, but it is also giving you the equation of the vertical asymptote. And that's what I call VA for vertical asymptote. VA. What is the equation? It is x, always put a letter, equal to what? 0. So let's show where that is. X equal to 0 is a vertical line passing at the value x equal to 0. And it's really the y-axis when you think about it. So the y-axis is x equal to 0, that vertical line, and it's our vertical asymptote. What does that mean? It means that if you were to take some points which are approaching the 0, let's say I pick this point here, this one here, this one, that one, what it means is if x is 2, okay, notice how far the curve is from the asymptote. If x is 1, the curve gets closer to the asymptote. Let's say here x is a half. If x is 1/2, then you have this point, and look at how much is the distance between the curve and the asymptote. So this distance gets smaller and smaller. So it's like if the asymptote is pulling the curve toward it. But is the graph of the function f of x is 1 over x, is it ever touching or crossing the vertical asymptote? No, it's never doing that, because if you ever had a point where your blue graph was touching, this y-axis, then the point of contact would have to have, let me show you what I mean. If you have x equal to 0 over here is a vertical asymptote, and that's really your y-axis. If the curve for f of x was, let's say, touching this axis in any way, or let's say it was crossing it, then we would have a problem, because any point of contact between the function f of x and the vertical asymptote x equal to 0, you would have a point on the y-axis, a point of contact, and that point would have for x entry 0. I don't know what the y entry is, and I don't care, because it's not possible that x could be 0 for a point which is on the graph of f, because x being 0 was excluded right here from the domain. Okay, notice a parenthesis right here. We don't want x to be 0. So that would be a contradiction with the idea of the domain for this function. So really, a vertical asymptote, no matter which function you're discussing, can never be touched like this or crossed by the graph of the function. So that's a very important thing. Later on, we will see horizontal asymptotes and slanted asymptotes. Those can be touched or crossed by the graph of the function, but a vertical asymptote can never be touched or crossed by the graph of the function.